No complaints? Good. I got one thumb. Appreciate it. Command and KubeCTL. Fuck you, all the kube control people. Kids KubeCTL. You got 3 seconds to take a picture of this. This is the slide deck. If I'm going too fast or something like that, you can just check out the slides later, and I'll publish this online too. So 2, 1. We're going to talk about Kubernetes. We're going to talk about specifically some real-world attack scenarios that I've seen in my experience, specifically targeting registries. We're going to talk about things called whiteout files. Anybody heard of whiteout files? Anybody? Great. Well, you're going to be in for some interesting new information, and here we'll talk about some new tools. So if you're doing Kubernetes and you've got like a pen testing background from like NetPens, you might look at Kubernetes as like, it's a bunch of IPs and a bunch of services, and I just nmapped a Kubernetes cluster, and you'll see here's some IP and here's some Nginx instance. Every pod, every container has an IP address, and there's this kind of like control plane model that isn't, you know, that new. But I like to think of Kubernetes as more of like an operating system where you're not paying attention to the IPs as much as like you would pay attention to like a process's PID. You know that it's going to get a PID. You don't really care like which ID it is. So in the same way that like there's IPC for an operating system, we have service mesh and we have like internetworking options. And for Kubernetes, the like underlying kernel is the Kubernetes API, if you will. So there's this separation of all the security controls and RBAC stuff that the Kubernetes API does itself. So if you think about it more this way, it fits, at least in my mind, a little bit better. Because I've had a bunch of experience with people like doing pen tests, being like, hey, I've wrote this pen test report. It said there was a vulnerability with Nginx on, you know, IP 1.2.3.4, and it's like, well, that thing's gone by now. There's no way like we can remediate or find out what that is. So I like this model better. That's kind of as far as I'm going to go as an intro to Kubernetes. This is like a 20-minute talk, so I'm sorry. I'm just going to give you some pointers to some books that I like. Production Kubernetes is cool. Andy Martin has got like a really nice book on hacking Kubernetes because it's like more of like a story. He's got this whole a good way of like being the hacker throughout the whole book. And I assume most people know about RAD security, but they're kind of one of the things, if you actually have to deal with Kubernetes clusters, one of the good tools that I've been using. So, real world scenario, in my mind, I'm going to bring up kind of like these two specific things that we're doing. So imagine yourself on a pen test. You might go, I need to do some recon on the environment that I'm pen testing. And you'll go out to the company name or whatever, the organization, and you'll start going to Shodan or Census and just finding like what public information is out there. 9 times out of 10, you'll find a bunch of registry information. You'll see a bunch of things. They're now tagged in Shodan and Census that say, you know, this is a registry of some sort. Maybe it's Harbor, maybe it's some external cloud hosted managed registry. But it's something out there and you go like, okay, I've got access to a registry. And in our scenario, and this has happened more than a dozen times to me, you have a private registry for your production environment, right? You've got a production Kubernetes system. You've got your kind of confined registry that your kubelet is connected to. But you didn't go so far as making like a staging environment. So all of your dev folks that need to test things are angry at you. So they've gone through and they've built some like shadow IT to set up a registry. Or it's like some staging registry, or even like the scenario of like they made the registry but it's just not as secure as your production registry. Let's say even you've locked everything down in production, but then you've decided, hey, you know, authentication is hard. Let's just make this thing public because I have a bunch of different staging clusters. So we're setting up the scenario, and this has happened many times. I don't know if it's happened to y'all, but the scenario of I've got access to a registry, what can I do inside of there? So if anybody's worked with registries, they're kind of like a blob store with a front end. If you look at how they're designed, it seems like they started with an S3 bucket and then like, let's put an API on that. Because everything is stored as these blobs, and everything's as a layer of the container is stored as like a tarball in this block storage. And Docker came out with this registry API. It seems nice, but they're kind of like, here's the minimum sets of the API you need to implement. And if you want to do garbage collection, you want to do security, that's all optional stuff. So you'll see Harbor is like an example of somebody that's bolted on a bunch of security controls. But then there's other like registries that some of the free ones that are out there that don't have any of that. They don't have garbage collection. They don't have tag immutability. So we'll talk about like kind of what some of this stuff means. So in our first scenario, we're kind of saying like, what do we do with access to a registry? We've got some token that was exposed, or we've got some unauthenticated registry. What tools can we use? There's a bunch that are already out there right now. Crane and Scopio are both similar in that they've got a bunch of different features. Crane from Google, Scopio from Red Hat. that will interface with a registry and do a whole bunch of features. I like them for pen testers because they're statically linked, so you can just kind of curl bash them down. So I don't know how many times people have been on a pen test, they've gotten a shell inside of a pod and they're kind of like, well, now what? So I like to have, like, nobody wants to like load, interpreted languages and the stuff. So having these statically linked binaries, you can just curl bash down and interface with the registries as you see them from line of sight from the pod has been useful. Dive is another tool that's been around. A lot of people kind of know about for just analyzing the images. But today I want to talk about a tool that I've been working on called reg pillage. So this tool is out right now. I wrote this in Python years ago. I realized why that was stupid. A friend of mine rewrote it in Golang. So Josh Mackinnon, when we were both working at a pen testing company, worked on this together. And then I've taken it because the pen test company has kind of like ruined it, and I've made a new version of this, added some new features. So the purpose of this tool is to go through and find a whole bunch of issues related to registries. So you can kind of point and shoot at registries. When you're on a pen test or you're seeing like you have line of sight into a registry, what can you do? So it extracts information from it. You can hunt for secrets. You can hunt for misconfigured images. I've integrated with TruffleHog just because, like, why not? It's just for hunting specific secrets. That's all nice, but there's a specific feature I want to talk about in this presentation. So imagine, if you will, here's your simple Docker file. We've got like Alpine we start out with. We copy some .env file because, I don't know, we need to like interface with some API during the build of our container. We do whatever we need to do, and then we remove that .env file. We go like, oh, it's a sensitive file. It's got credentials or passwords in it, so I need to get rid of that thing, and like everything is done. The way that, and if anybody's looked into the way that images get built in container registries, they start out with that base, when you say from Alpine, that's a layer. When you do that copy command of that env file, that's a layer. Whenever you run and whatever you change in the operating system from the file system perspective, that ends up being a new layer. And even like when you remove something, each one of these pieces for almost every line that you make on that Docker file becomes a new layer. And a lot of people know about this because it's bloating our files. When you've got these people, somebody just told me they had like a 60 gig image, and I was just like, what are you? I can't even imagine what you're baking into this thing. But this is kind of one of the problems where you just keep adding more and more layers to this whole thing. From the registry's perspective, you would say like, okay, that yellow line there, that's a tarball. And that represents one layer, that's Alpine. But each one of these images, if you're going to download like Nginx or HashiCorp Vault, they will be stored on the registry as like a manifest, and the manifest just has these simple pointers to the layers. You go download to each one of these layers. So if you've ever like done a Docker pull, you've seen it like that parallel operation that shows you like, I'm downloading 4 different layers for this one image, but at the end of the day, like, you don't see that. The container doesn't see that when you run it. So everything gets squashed down, and you go, well, okay, if I add a file, it creates a tarball. You look at the yellow one, okay, that would be the root file system. It's going to have a lot of files in it. The second layer was we added a .env file into it. So we would imagine that inside the tarball, we would see a .env file inside of there. And then that purplish one, that was where we changed something. And then we did something where we removed a file. So what happens inside of a tarball when we need to remove something from the tarball? Like the other ones we said, oh, adding and modifying, that makes sense. I'm going to put a copy of the thing that I modified in there. But how do you remove something? And all of this is eventually getting squashed. So when you talk about an overlay file system, if you've got a root shell, none of this stuff is visible to you inside of the container. You're not going to see, oh, there's some hidden file like in some layer that's accessible to you. The overlay file system takes care of this, so there's just one base operating system that just gets squished together. But that doesn't mean that the file is not there anymore. When we're looking at the registry, that file that you originally saw will have something called a whiteout file. And there's 2 reasons that you remove files in a container registry. You want to debloat it, like everybody's done that thing where you do like apt install something and then you do that, like remove whatever the apt cache is, just because you don't need that connected there. Debloating is, I don't really care about, like that's an important thing that we should do, like that's cute and stuff, but the other reason to remove stuff is because you're hiding it. And a lot of the times you'll see something like, well, I needed to like copy in a signing key, do a signing operation, and then I don't want the private key stored inside of that container, so I'm gonna just delete it. So this is where these whiteout comes into place. Every file that gets deleted inside of that tarball doesn't get like, how do we tell the overlay file system to delete a file? what you do is you prepend it with a .wh inside of that file, and then when the overlay file system sees that, it automatically just gets rid of the file. It just won't pass it inside of there. So you'll see a bunch of these. If you were to take all of the layers, and you were to extract them as tarballs, you'd see a bunch of these .wh files. And so I've added into PillReg this feature that will hunt for these .wh files and then look for the original file that was in the previous layer. So it goes through, you're not sure really which layer goes in, so it kind of hunts through each one. It sees that there's a, like a whiteout file in layer 5, goes up to 4, 3, 2, 1, and tries to hunt for the original file that was there. The purpose for this is if you're trying to hide something, it's most likely that you're doing it with these .whiteout files. Like you're trying to delete something on purpose. This gives me a more targeted way of finding secrets or things that you're trying to hide from me. So this command you can point and shoot kind of at any registry right now. And then I've also added in a filter that will remove all the stuff you're doing with like APK and like removing old libraries and modules and cache stuff. So how this works, if this works, I've got a Docker file that's just basically going in and it's going to like sign some images. It's going to like build a binary. It's using cosign in there. You can see that it's importing a secret key, and it's importing like a Docker config. So both of those files, you go like, well, I want to sign the image after I go through this build. So this is like some kind of build container. We're signing it with the signing key that's private, but then later after we do the signature and we do the cosign operation, we remove it. So when we go through and we build that, it uses the private key during the build process, it compiles it down, and now I'm pushing it up to like my local registry, but this would be like the production registry that we were talking about. And this gets stored inside the registry, and then when we point it as the attacker, or like somebody during a pen test, and we just point it at the registry and we say like, show me all the layers and show me all the information that you can find just looking for these whiteout files. It'll look for any of these files that you've been trying to extract, and it'll find these two layers. So you'll see a signing key and a Docker config, pulls all that stuff out, dumps the results for you, and now you can see that the files that were hidden for you. So these two things show you how to access secret whiteout files inside of the things. There's no tools that I know of that are working on this right now. So if you're playing the Kubernetes CTF right now, big hint, you might want to check out this tool for one of the challenges. So the other aspect of this is like writing to the registries. Let's imagine the scenario that Docker config file had like credentials so that it's not just like reading to the registry or like some unauthenticated registry, but there's been a bunch of times where I've been on a Kubernetes pen test and they've given me like read access that they thought was read access. Turns out it's read and write. Or maybe you've compromised some CI environment that's pushing to a registry. So some malicious stuff that you can do with write access to a registry I think is interesting. Anybody not know HashiCorp Vault, or anybody want to admit, like it's kind of a ubiquitous secret management engine. It's open source, or at least it is for now. IBM just bought it. It's designed to like just be better than etcd is really, so it's kind of a low bar, but it's designed to like cryptographically control all the secrets in your Kubernetes cluster. I like it from an attack perspective because when you run it, there's this operators model that has like every node has an init container of the vault thing that it does, that it will negotiate the secrets and pull it down from a server. The server that gives you the thing. The name of the image that the server uses is HashiCorp/vault. The name of the image that your init container uses is HashiCorp/vault. So when I poison one of these images, I get the 2-for-1 deal around I can take over the server and I can take over the individual nodes. I like the individual pods because they cycle more often. So how would we actually go through this? Like, okay, let's backdoor vault is what essentially where I'm going. What would we do? We put something malicious in there and then we just like upload it to like latest. There's a bunch of subtlety here because hopefully nobody's running in production like with the latest tag, right? Anybody running in production with latest? Yeah, you don't want to admit it, right? There's some interesting subtlety here because some registries will do tag immutability, which is great. Some registries don't support that. It just means like you can overwrite an existing tag. Some registries get confused between digest and tags, and sometimes you will see, for example, HashiCorp Vault, it'll have a tag of a SHA-256 hash. And it's not a digest, but it's a tag. So you can have the digest under the hood be, SHA-256 ABCD, but the tag can be a completely different one. So when these tags are not immutable, that means I can modify the tags of these images and I can push them no matter what the digest is. So I'm going to push up HashiCorp Vault. I've backdoored it. And I'll call this like the Kaminsky method, to shout out to Dan. We're going to exfil all of the DNS. We're going to exfil all of the secrets over DNS. And what I've done is use the Exodus custom DNS server. So whenever all the secrets are accessed by either the server or by the sidecar, it's going to send all of the information back up to my server. And I actually did this, so if anybody wants to do this, feel free. This has been working on Pentest for at least 3 years. It's public, and even the image is hosted on Docker Hub. Another reason not to use Docker Hub, it's where I put all of my malware. So this is a simple patch, and to be honest, it's statically written to, exfil to me. So if you want to use this, please do. I love all your secrets. You can send them right to me. But you might want to, modify that one section of the code. It's all open source. It's basically just adding a simple function. I'm not trying to be covert, right? I'm not talking about red team stuff and just demonstrating. So the host I'm connecting to is exfil.antitree.com. So any good SOC operator is going to see, literally the host is named exfil, like something bad is happening. So to summarize it all, it's kind of like, okay, Vault is connecting to the registry. We're pushing our backdoor Vault to that registry. The kubelet pulls down the image. We go to run the pod. Everything gets backdoored and sends all the stuff to me. Hooray, cute. Let's do a quick demo just to prove that I've done that, and you can use this yourself. So when you run Vault, here's the server side. It spits out really, verbose information to standard out just to show you that I'm doing it there. And then on the server at the bottom, you can see all the tokens that I'm collecting. So this gives me all of the tokens for Vault. So anything that you've stored in Vault, including the service account tokens that needed to be accessed for the pod itself. So the question comes into, okay, now you've got access to a cluster. What do you do? And this is, the more interesting thing. I've only got a little time to talk about the most useful tools to me. So first of all, I hate KubeCTL. The different switches, if anybody's had to use it, you've got to memorize 250 different things, and it feels like the CKS exam is always just about different switches for KubeCTL. K9s is the best tool because one, it's statically compiled, just like I've been talking about the other tools, so you got the living off the land type of thing. And it lets you have a text interface to do simple things of here's this pod that's running, I'm going to hit S and I'm going to drop into a shell. So you don't need to have you don't need to install anything in the cluster, you just run it from wherever you are, and whatever tokens you have access to, it'll use. You can audit RBAC with it, you can access different shells, you can create different shells on nodes. So super useful both on red and blue side. The other one is Crew. Has anybody heard of Crew? I'm just yeah, okay. KubeCTL, if you hate KubeCTL, again, it feels like I'm just hating on KubeCTL. Crew is the plugin system for KubeCTL that you can say, I'm doing this one operation over and over, I'm just going to make a plugin for it so I can just run KubeCTL, my tool. So there's now, last time I looked, there's over 500 plugins for this thing. A lot of them are related to security. One that I put in there called NetForward does a bunch of reverse shell stuff. Access Matrix is useful. But just a simple example of who can. You've got built into the API of you can, probably a lot of people know the auth can I, with my service account token, can I do this? But the who can is the inverse, where we can say who can access secrets, who can do something inside the cluster. So a lot of really interesting tools. The other one is Paratis, made by Inguardians and my friend Jay Beal and a bunch of open source contributors. This is the Metasploit of Kubernetes. If you want point and shoot exploitation of Kubernetes clusters, ask no more. This is kind of the thing. It's open source, you can contribute to it. There's been a lot more contributors to that. So only got a few minutes left. I want to talk about some of what did we do wrong? What was the problem? What is the thing that we're actually exploiting? One of, you may have seen the root issue is that in the original Docker file, we had two separate layers between the copying and the removing of the thing. So when we copy the environment file and then when we remove it, it makes two separate layers. If you did that in one single command somehow, and it's not always possible, that layer wouldn't exist. And if you use the arg option inside of the Docker files, you can pass in the arguments external to the build environment so that won't be exposed there. The other one is I'm uploading malicious stuff to a container registry, and you can't really tell which one is the malicious one and which one is not without looking inside of the thing. So it's 2025. Everybody should be signing container images and verifying them. It's pretty much low cost. You can do the old way of like having a long-lived secret and sign all of the images, or you can now do like keyless signing, which is like a stronger auth method. That's kind of a whole separate talk. The other thing I should mention is like in this Docker file, as I'm going through it, we should point out that like I'm trying to do cosign in the middle of my build job. So like as all the things are going and as the thing that I'm attacking is getting compromised, I'm also doing the signing operation. And that means that when I compromise the container, I'm also compromising the signing key and all that stuff. So the point is, when we sign stuff, it has to be out of band from the normal build process. It has to be extracted, and this gets into the whole salsa world that we can dive into. Registry auth, and just for time, I'm going to skip over this one. Obviously, we need better auth. There's smarter ways to do this. So just to wrap it up, we did a 2-slide intro to Kubernetes. I'm sorry. We're talking about like attack scenarios of specifically registries. We talked about a couple tools, but I want to ask you all a question now. You've compromised the Kubernetes cluster. You're like a real-world attacker. You're not a pen tester, red teamer. You're not like a black hat presenter. What happens to your cluster in the real world when somebody breaks into your Kubernetes environment? Just shout out answers. Like, I heard a pivot. I heard cryptojacking. Anybody else? Yeah, it's you said it's like crypto miners, it's cryptojacking. It's like we've got all these like really sexy exploits where we go like, and this is how I pivot, and this I go into these registries, and I can talk about like cool container breakouts that I really love, and like I'll use them on a pen test. But we still don't have those really smart, real actors that are taking over Kubernetes clusters in like meaningful ways. So we have to be honest with ourselves of like humans are kind of bad at risk analysis and knowing which things to mitigate. So as we're building these clusters, we're thinking about like which ones should we be working on. Humans are thinking like terrorist attack. That's the most prevalent risk we need to worry about because it's the biggest impact. For Kubernetes, we have the same problem. We go, oh, container breakout is the scariest thing, or registry breakout is the scariest thing. But it's like overprivileged RBAC is actually the most likely thing, or like the thing I did just last month to one of my clusters is like kubectl delete in the wrong context and like take down production. So, as we're defending things, I can talk to you about like the registry and like the stuff we're doing as pen testers, but like we also have this responsibility to simulate what a real world pen tester is supposed to be doing. That's all I really have time for. My name is Mark Manning. I come from a background of like doing a bunch of container security stuff for a pen testing company that no longer exists. I worked at Snowflake doing secure Kubernetes, building their secure Kubernetes offering and trying to harden that from the ground up. I've been doing a bunch of work with gVisor and QEMU and trying to get into secure build stuff. And now I'm working at Chainguard trying to actually secure some of the containers from the ground up and the overall software supply chain. So that's all the time that I have. Feel free to ping me. I'll be in the hall to talk more.